Okay. When you're doing these graphs, and I've done these graphs, I'm not gonna do them, except for reference. And then I'll do them really fast, the way I want you to be able to do them. Okay? You know how to do them. Just do them a few more times, so you can do them really fast, like so you can construct one of these graphs in a minute, including the table, maybe without all the calculations. Okay, so just slop down a table, slop down a graph, sloppy as it needs to be to get it done in a minute. All right. And then you know you go to one of them for the reference. Okay, well, anyhow. First place, I do the graph. Exaggerate. Wrong with that?
There's no even spaces.
I'm sorry, asking questions and getting an answer, so let's try again. Okay, now this is an exaggerated version. And many of you are using too many points. You know, you're running points from -10 to 10 when you're graphing in an interval from -2 to 2. Now here, probably went from about -30 to 30 or something like that. And nobody did that. Okay, you go from -10 to 10. Well, it's probably out of habit, which means you learned something. Okay, that's understandable. But you want to get out of the habit because you don't want the graph look like this. Okay. You can't make estimates on that. You can't visualize what values are and so forth. Okay. So as I've said before, and not going to repeat it too many more times. Just because there are other things I need to talk about. I'm repeating it. I just, love saying this. Okay. But basic functions. Now it's always labeled -2. Said -2, so I wrote -2. Okay. And then we subdivide this interval. Get 1, -1, and 1. Then we subdivide this interval, get -1 half. Okay. Then we apply the y interval accordingly. Okay, so what I want to talk about is domain, range, and functions. And you'll have an assignment on functions next time. So I want to kind of concentrate on that. But I want to be certain what I mean by domain. So if I have it. Or my values, okay? Now, 1 over x is going to be -1/2, -1, -2, undefined. And if DNE is what? Open math went to right for something that doesn't exist. Now you got 2, 1, and 1/2. Okay. So the domain, what we call the domain of this function. 6. Doesn't include 0. Because you can't calculate, I mean, the value doesn't even exist for 0. You just can't calculate it. So here's my limit. On a range. I want to change this to 1 over X. Of course, is one you did. Great. Yeah, do range. Okay, so the range of this function is a set of values over here. So the range is what I've circled in blue. If you want to write out the range, well, we're going to generally write them the lowest number to the highest. That's kind of the way we used to read it. Right there's the range. You notice I didn't repeat these numbers, okay? Because this is a set. The elements of the set are 1, 4, 1, 4, and that doesn't change just because all those numbers occur twice. In other words, the question is 4 a member of this set? You don't need to have 2 4s here to decide whether 4 is a member of the set. Okay. So that's why we only list any member of the set once, even though it occurs twice in our table and occurs twice in our graph. Say something else. Hang on. Okay. If I graph this function, I think everybody graph. Here's 4, here's -2, here's 2. You know what these other numbers are. The -2 we've got a value of 1/4. One we've got value 1, and at 1/2 that value 4. So kind of label that inconvenient place. That's not a convenient place. Okay, then 4 we've got this, 1 we've got this, 2 we got this. Okay. Now, if I draw the curve, then I have additional y values on the curve. So the basic function consists colors here. The word started to read consists only of purple points. I use a terminology that open math isn't going to use, but I want to distinguish this. So I'm going to say the extended basic function is the curve. Now notice that I haven't extended the curve past 2. I haven't extended it past -2, and I haven't extended it up above 4. Just the curve on the domain. What's the domain of this function? The domain consists of all the x values. Okay, so what can you tell me about x values? They go from -2 to what? Talk about this for a second. Oh, man, I didn't record any of that. Well, that wasn't good enough to go viral anyway. Apparently, the rain's got me a little bit slow this morning. I'd anticipated this, I'd use caffeine. But I avoid that because after a while it doesn't work well. Okay. Okay, now I didn't record what I thought I was recording, so let me go back and say things kind of quickly. We got the 1/x² function. Okay. We got the table. I've circled the numbers in the domain because the domain is all the x values. 0 is not a number that works in this function. Undefined for a reason we've talked about. So right there is our domain. Our range consists of numbers in this column. Okay, the numbers are 1/4, 1, and 4. We only have to list them once because this is a set. Set allows us to determine if a number is in the set. So it's 3 in the set. No, don't see it. Okay. How about 1/4? Yeah, we see that. Okay. We don't have to see it twice to know it's in there. Okay. Now, everybody, I think, came out with a good graph of this function, at least everyone I looked at looked good. And I think it's pretty straightforward. I think people know how to graph this. So the graph of the basic function, what I'm going to call the basic function, consists only of the purple points. Point here, here, and here. Point here, here, and here. Now, as we're used to doing, we can draw a nice smooth curve that connects these points. Okay. Now we don't know. I mean, maybe we kind of do know, especially in light of some of the things we did last week. We don't know what happens between here and here, but we do know that this point doesn't connect with this one because if it did, it would go through the y-axis. If it goes through the y-axis, then you're assigning a value to 0. And it's undefined. It doesn't work at all in that function. So if you wiggle around and go through the y-axis at x equals 6, then you're telling me that 1/0 is 6. And I have to tell you, I think you're right. Okay. Let's think that through a little more. Okay. That's probably good that I'm repeating this because it wasn't on the screen. Okay. So I'm going to say what we call the extended basic function is the smooth curve that goes from here to here. Doesn't go beyond this. Even though we kind of know we're going to get a vertical asymptote. We're not going to go beyond this point. And then it's going to start here and go to here. It's not going to go past 2. It's not going to go past -2. That's what I call the extended basic function. I'll distinguish that, and just what I'm saying, from the complete basic function, which does go beyond 2 and goes beyond -2. The pattern should be clear. It's going to get really close to the x-axis. Goes that way. And if it goes this way, so that the x-axis is a horizontal asymptote. And we're throwing that idea away, but to become important later. And it should kind of click through. And then you have vertical asymptotes. Okay, now what we did last week, we moved twice as close. We moved twice as close to the y-axis. We moved twice as high. What's happening here? I move twice as close to the y-axis. That's like from here to here. Well, I'm at 1/4 and I go up to 1. I go 4 times as close. And then if I go twice as close again, I go to 1/2, negative 1/2. Then I go up to 4. Well, I went from 1 to 4. I'm 4 times. I said it's close, 4 times as high, 4 times as far from the x-axis. So the rule for this function could easily be, you go twice as close to the y-axis, you go 4 times as high. And once you understand that, and you should, because I think you understood it well last week about going twice as close and twice as high, that gave us a 1/x function. I think we talked about that. So if we keep going twice as close, we go 4 times as high. It means we shoot up there really fast. Okay. So go 10 steps here and we're miles high. And we're not going to do that, obviously. Okay. And actually, no, if we go 10 more steps, we're not miles high. We're about 500 feet high. Okay. There's only a 1/10 of a mile. Go 10 more steps, you're 100 miles high. So we get a vertical asymptote. And I think people grasp that. Okay, well, now we wanted to list the range of the extended function. The range consists of all the y values. So I'm going to draw a picture. The x values go from -2 to -1/2. And from 1/2 to 2. And I use solid dots here because you should be familiar with the idea, but it's easy. Solid dot at the endpoint of a line segment means that the value there, in this case 1/2, is included. Okay. Well, there's my domain. X is -2, -1/2, union 1/2, 2, right? There's a picture. If you're -2, -1/2, and you're 1/2, 2 intervals. Picture of your domain, picture of your range. I just shade everything on the y-axis corresponds to a point on the graph. Okay, well, the highest point is going to be 4. And the lowest point is going to be 1/4. And there's a y value for every x value between 1/4 and 4. So we can say that the range is the interval. And I saw this in most of your papers. A couple of you did paper pretending you didn't know. Just to make me feel like I was doing something helpful. And I appreciate you doing that. Everybody needs to take turns doing that for me. Okay. But most people listed this interval. And I'm not sure exactly how you were thinking about this. Maybe you looked at this and said, okay, we'll go from here to here. That's not bad. Understand in terms of the graph, that's even better. Okay. And we could even go like with the range, which would go a little further. Okay. Points on the graph. Stop here, but all the y values between here and here get taken up. If I did projection lines, these points over and from these points. Okay. Okay, good. Well, that's a visual picture of the graph. Now, and that's the idea of domain and range. So you should be able to do the domain and range. Tell me what the domain and range of each basic function is. The domain and range of each basic function will consist of opposed 7 numbers in each. Okay. sometimes only 6, sometimes only 3. The domain and range of the extended function, if I ask for that, I'll explain what I mean by that. You have to know that terminology. And it's not a standard terminology in mathematics. But I kind of like the way it works because you understand these functions, you understand the graphs, and it gives us a handle on difference like between a set of points, which will have a domain and range that's discrete. Discrete means they're not all connected, they're all separate. Okay, and continuous, which is what this is. This is nice and continuous. All the points are filled in. Important ideas, important terminologies. And you might get the terminology in that responsive form at this point. If you remember, that's great. Okay. Now, for this function, we could write y equals f of x equals 1 over x squared. So and the complete basic function would be this. And I'll specify the domain. It's just saying x is not equal to 0. Now any number except 0 can go into this function. Okay. If I want to evaluate this function with x equals 3, well, we have this rule that says f of x is 1 over x squared. If I write f of 3, that means x equals what?
3.
Yeah, thanks. Okay. Make sense? So what's f of x equal to? Show me with your fingers. Yeah, 1 over 9. Okay. And it's this fairly simple function notation. It's really pretty simple until it isn't. And in a minute, it's going to get isn't. Okay, but f of 3 is 1 over 3 squared because the rule says f of x is 1 over x squared. When I write f of 3, I just said, okay, from now x is 3. What is f of x? Well, if this x is 3, then this x has to be 3, and you get this. Okay. Okay, so I'm going to ask you to write out a few. I expect people to pretend to be confused in some of these, even though I know that everybody's going to understand it completely. Okay. Seriously, when I do this in class, there are certain confusions that we always get. Now, y'all could make a liar out of me, and if you want to, I would welcome it in this case. Okay. So I want you to tell me, first of all, what's f of -4? And f of x plus h. We've done this. We've done f of r bar. I don't think so. I did it in the MDE 61 class, but I didn't do it here. Because in the MDE 61 class, we're way ahead of this class. Except that we're not doing the harder problems. Okay. And MDEs, people are showing up for MDE are doing really well. Okay, anyhow, f of r bar. So we want to see maybe what that is. And of course, if you were in the MDE, you got a little head start on f of g of x, okay? Okay, but once again, people did quite well on this. Some people pretended they didn't understand one thing or another, or read something into it, just so I, again, feel useful, and I appreciate that. Okay, so f of -4. Well, again, the rule is, whatever replaces x is what's in here. What's in here is x. Replaces x in the whole definition of the function. So that means if you just take that literally, f of -4 has to be 1 over the square of -4. Now do be careful, because a couple of people wrote a -4 squared without the parentheses around it, which means you're squaring the 4 but keeping the negative by the order of operations. Want to be careful about that. Get that out of your system. Okay. I know I made that mistake at least once. Okay. But once I realized what I'd done, I don't think I made it much anymore, but I wanted to make it several times. Okay, so you got to be careful about the rules, check everything against the rules. Okay, so anyhow, -4 squared is 16. So that's what I got now. A couple of people left off the parentheses. Still got 1 over 16. Which is wrong, but right. Okay, f of x plus h. Well, now x has been replaced by x plus h, right? So this is going to be 1 over square of x plus h. Now I see a lot of wrong errors, a lot of errors when I first give this in a typical class. Okay, I'll get 1 over x squared plus h up there somewhere else. Okay, or 1 over x plus h squared. Okay, but all it says is you replace x by x plus h, and that is what you get. So you don't want to read anything into it. You want to follow the rule very precisely. Then you can do the algebra of this. And incidentally, if you square x plus h, you don't get x squared plus h squared. You get x squared plus 2h plus h squared, because you have to use the distributive law. Okay, that's a very common error. And I've made that one more than once. Okay, because you're in a hurry and you just want to square everything. I got it out of my system pretty quickly. I didn't make that. I know I made that. Okay, f of bar. People did pretty well with this. Now, I don't even know if r squared is fine. How does one square an aardvark? But if it is somehow defined, that's what you get. Okay, it might be an absurd function. Well, certainly it is. Okay, unless aardvark is the name of a variable that stands for something. Okay, what about f of g of x? Well, g of x is now replacing x. So this is 1 over the quantity g of x squared. And this will lead us in the fairly near future to the idea of composite functions. And you've probably seen them. If you understand function notation, if you understand how you're just replacing x by whatever's in the parentheses, and you replace all your x's by that, then you're off to a good start. You have the mechanics of doing composites. And the details of what you do with composite functions, well, those details can become kind of complicated. One of the first stumbling blocks in calculus is what you do with what's called the derivative of a composite function. People have trouble understanding it, even though there's a simple rule for it. If you learn now to follow simple rules and remember what the rules are, then when you have to take the derivative of a composite function, maybe a year from now, it won't give you as much trouble. Now, understanding why the derivative is what it is, well, that's something you want to try to understand in an engineering or a calculus course that's aimed at engineers and mathematicians and physicists, and, people in the hard sciences for the most part. The applied calculus, you don't really worry about why it works and why it doesn't. But if you do a good job in this course, you might get some insight in why. And it can be helpful. It helps you not forget about the composite function. The important thing is the interpretation of composite functions and what they tell you. So you don't need to understand much of what I just said, except take away from this that composite functions are really important. Because in almost all of undergraduate mathematics, except for physicists and math majors and such, pretty much all the functions you use are these basic functions. Now there are a few more, but the main behaviors, the three we did here. If you know those three, then you can easily figure out the other two. And then you can easily figure out all the rest of it. And almost everything you do with mathematics is based on those functions. Transformations of those functions, and transformations have a simple idea. Some of you jumped a week ahead in the assignments and tried to do the assignment for next week. Okay, a week early. We hadn't talked about it. We'll talk about it next time. In transformations, you essentially just take the graph, and here's your x-axis, and you either lift it up or lower it. You can raise it and lower it. Called a vertical shift. The graph retains its shape, just goes up higher or lower. It's really simple. Or you move right or left. And visualize it. Just visualize this graph. Move it to the right, and your asymptote is no longer the vertical asymptote is no longer the y-axis. Okay, if you move it 10 units to the right, your vertical axis is the x equals 10 line. Okay, and if you move it upward or downward, that changes your horizontal axis because the x-axis it changes your horizontal asymptote. Your x-axis is horizontal asymptote. So it's once you understand that scheme and then learn how to do the algebra, you've got a good picture of these functions. And then we deal with some applications so that you can begin to apply these functions. And then you get a nice little bundle of knowledge. Okay, we're starting here with pictures of graphs. We'll be moving into a little bit of algebra. And we're going to build the algebra so that we understand what's going on with the graphs better. Okay. And we start with graphs because they're easy to visualize, they're easy to make. And coming out of COVID, algebra preparation is not so hard. Okay. So I want to give you that time to adapt. You got the basics. You'll be able to do it. But we introduce it gradually, a little bit of time. Okay. Okay, so we're going to stop having fun and talk about the series. Y'all done real well. You have my name, Dave Smith. My office, got one over in the ISC building, 102. Or do I have 102A here? Yeah, okay, 102A. My office is officially back in that storage area, but I'm out here. Okay. And OTC 220, which is the office in that direction, that's furthest from here. Okay, it's on the second floor in the park. Easy to find. And we got a phone number, but I really don't like to use the phone. Partly because I don't hear real well, some people are hard to understand. Plus, you can't really do mathematics over the phone. And you can't really do anything over the phone that you can more easily do by email. And then you get my reply. So if you tell somebody I said this in the office and it's wrong, I didn't say it, got legal defense. Seriously, it's just, you can clarify things. And if you have an email that answers your questions, and I find that that works really well for most people, then you've got something. Whereas you forget 90% of what anybody tells you. Some of you may be 89%, some 91%. Understand? Okay. So voice messages are just unreliable. Don't like to use them. So I would say use email primarily. And it's got my office hours. Like every morning. I don't have them officially on Thursday, but I've usually got the computer on and check the email. Because I do it every other day, and sometimes I forget what the day is. And from right now, it's from 9:40 to 10:40. I find that pushes me a little bit because I'm doing those from home. Pushes me a little bit getting here by 11 o'clock sometimes. Doesn't really push me. It's comfortable getting here by 11 if I'm done at 10:40 because I don't live that far away. And traffic. I've never seen enough idiots in the road or hostile lights. Traffic lights, aren't that many traffic lights that I haven't been able to get here on time. Given no other questions. But I might move those 10 minutes earlier, like 9:30 to 10:30. So in case I need to get up here and like print off a syllabus, I have time to do that. Okay. And if I do that, I'll send out an announcement. Then relevant to this class, I've got an hour after this class, then I've got 3 hours after Thursday's class. Monday and Wednesday, got 3 hours after Monday's classes, not on Wednesday. Okay. Okay. We got the course title and description. That's the official PCCS title and description. There's prerequisite knowledge required. Supposed to know knowledge in MTE 1 through 9, or co-requisite MDE 61. And I'm not sure we even want to refer back to the MTE courses because they've been going for a couple of years. Okay. Now I just turned the page. I have no idea where I am. Let's turn 2 pages. Yep. Nature of the course, you get a pretty good idea what the nature of courses. This is how we work. Okay, I'll talk about things, we'll do some work, I'll look at what you're doing, I'll adjust what I'm saying, what I see. Try to give you a head start on the homework. The homework is in my open math, it pretty much always has video support. Those videos are pretty good. And I think I mentioned their video on the 1 over x cubed function, or the x cubed function. Somebody needs to fix that. It doesn't have the right shape. It doesn't go 8 times as close. Or yeah, 8 times as close every time you go twice as far. And you get a really distorted graph near the origin. The thing comes up, it actually levels off at the origin just for an instant and then goes up again. And they drew it so it goes through at almost a 45-degree angle. And that's really important. I can't believe they did that. Whoever did that video. Otherwise, the video is pretty good. Quarters at that point are definitely not 1/2, 1/8. They're like 1/2, 1/4, 1/2, 3/8, or 1/2, 1/2. It's pretty awful. It's an important omission. And it's rare in open math that they do anything that bad. Keep it on. Okay. So you understand, you assign much of homework through open math and so forth. This thing about a project, we might or might not need to do that, and we'll talk about it. Okay. Written homework to do prior to the beginning of class, the day assigned, etc. And you gotta you gotta write things legibly. One side of smooth, full size sheets of paper. Okay, that's for all submitted work. Tests, everything, because I like to run them through a copier sometimes, through a scanner. If you've got a disability, I haven't gotten any notifications of disabilities. If you've got a certified disability, let me know because I haven't received anything on it. Broad goals and purposes of the course is basically to get ready to take calculus and to learn some really good and really important mathematics to benefit you if you go into your intended curriculum. Specific objectives, each problem is specific objective solving. We have conceptual objectives. I'm not going to read those to you because they won't really make any sense at this point. But you should read these every week. Okay, a couple of pages of them. When you get to the point where you're not understanding anything, well, stop reading and understand. A couple of weeks later, you're going to be able to read further and understand what you're seeing. And mechanics and manipulations similarly, and problem solving similarly. So come back to some of these. But if you can see what we need to do. Areas to be covered. Modeling real world phenomena by using graphs, functions, we've just seen functions, equations, and conceptual computerized models. Okay. And we do the algebra of functions, is what I was saying. We start defining functions. We start doing algebra with them, so we connect that with the real world phenomena and stuff that you're going to need to connect it with. Then we have systems simultaneous equations. Okay. Two equations and two unknowns, something you've almost certainly seen. We build that a little bit and do some stuff with matrices. Once you understand what's going on in simultaneous equations, the matrix stuff is practically the same as what you do with the symbols, just a little more compact. And then we have this matrix multiplication thing, which again isn't difficult to understand once you understand the equations. Graphical representations of characteristics and algebraic analysis, and then really importantly at the end, study of rates of change and related graphical considerations. And we went over quite a bit of that in MDE 61. If you're really, really interested, you can look at their videos. Okay. And I just tell you what the functions are: linear, quadratic, that's your x squared function, polynomial. You have like x squared and x cubed functions, you get a polynomial. Rational, polynomial divided by polynomial. Exponential, that's your 2 to the x function. Logarithmic functions, that's an inverse to the exponential function. And we haven't talked yet about inverse functions, but to get the table for an inverse function, you just switch the columns. And then that does things to the graph. The y's become x's and the x's become y. And then you try to do that algebraically, and that gets you a little hairy. We'll be doing that in a few weeks. Got the textbook. It's essentially the MyOpen Math text, but you have a link to the textbook in your math page. So you can always link to the textbook, and if you've seen it, if you've done, that when you start doing the assignments, you'll see that for every assignment, there's a text link. You can go to the text right there. If you want the whole text, the open math text, it's free. OpenStax text, sorry, it's free. You can order a bound copy for, I don't know, $50. I don't know what the charge now, but it's all free. It's all OpenStax. It's a good text. Gets the job done. Okay, the grading policy, which you're really interested in, you weight different things. Homework is given a weight of 2, quizzes are given a weight of 5. So quizzes count 2.5 times as much as homework. Participation is given a weight of 1. Don't participate. You're participating, you're doing good. A project is given a weight of 1 if you do it. Major quiz weight of 2 or 4. It's either twice or 4 times what the homework is. And you got to do the homework. Okay. Homework has enough weight that you're going to lose a letter grade if you just pull off the homework. And then they're not going to learn anything, which is going to be even worse for everybody. Midterm exams given a weight of 6 and the final exam a weight of 8 or 12. Okay. Whichever is better for you. There's common assessment at the end of the course. I've designed a blank thing and I administer it. It's turned into a real can of worms, but it's getting good results. You see how that works. Tests are graded in a 10-point scale, problems are graded in a 10-point scale. And you can read that. Emails have to come from your PHCC account, not from your personal account. I've talked about that. Partly I can't keep track of them. Also, I can't exchange confidential information. Don't use Canvas email. Okay. It's limited. It's Canvas, which has its good and bad points, and that's one of the bad ones. Supposed to attend class. Okay. Again, students with disabilities, it's in there twice, editing error. Academic conduct policy and academic integrity. Read our handbook. Don't cheat. Don't help anybody else cheat. Bad way to learn. So you can read that. There's a note about college-wide emergencies and links. In your phone or whatever. Got deadlines. If you want to drop this class, you get a refund. That's 14th, a week from tomorrow. Okay. And withdraw without penalty, 2nd of November. That's if you haven't done substantive work by the 4th, you may be administratively dropped. And I'm required to administratively drop you to 6 points. And also, if you're way below passing, haven't done any homework, haven't done anything that looks like you're even conscious, I'm going to drop you out of the course. You can apply for reinstatement if I drop you, but I don't want you to waste your time and money here. Also, financial later educations, the college, if we leave you in the course. Got tutoring available 24 hours a day for brain fuse. Got tutoring available in the market. Let's talk about that. Okay, any questions? I'm gonna turn this off.